All right, in this video, we're going to do section 2.6, which is solving radical equations and solving equations with positive rational exponents, which, as you remember, rational exponents and radicals can really be translated into the same thing. This is a nice, simple section. We just really have these three examples. So the key to solving radical equations is using the power rule. The power rule says that if both sides of an equation are raised to the same power, all the solutions of the original equation are among the solutions of the new equation. What this means is we can raise each side of an equation to the same power, just like we do with the properties of equality. But it's a little bit different because we are possibly introducing new false solutions, all right? And that's because, remember, if you have a square root and you square it, we really don't know kind of where our positives or negatives go. So when we square stuff, we kind of lose that negative information. So here are the steps to solving our radical equation. Basically, you want to isolate your radical on one side of the equation. So that when you raise both sides of the equation to the power of your radical, usually you're going to square it, sometimes you're going to cube it. It removes the radical from that side. All right. In the event, though, that you have more than one radical, you're going to have this one radical at a time. Okay. Once you get rid of your radicals, you can solve. But you really want to check all your solutions to make sure they make your equation true. Okay. So we'll start with our first example. The square root of 3x minus 5 is equal to 7. And let me open up my whiteboard. So we've got the square root of 3x minus 5 equals 7. The radical is already isolated on the left-hand side, so we can go into squaring both sides. Now on the left, since we've squared a square root, we just end up with 3x minus 5. On the right-hand side, we have 7 squared, which is 49. We're going to add 5 to both sides. What is that? 54. And divide by 3. What is that? 18? And we get that x is 18. Okay. Now we just have to make sure to check our answer. So our original equation is 3x minus 5. Square root of that equals 7. So we're going to plug in an 18 for our x and see what we get. Well, 3 times 18 is 54. So we've got the square root of 54 minus 5. Does that equal 7? 54 minus 5 is 49. And yes, that does equal 7. So we are good. X is 18. Okay. So that's a very simple example. Let's do this other example where we've got the square root of x equals the square root of x plus 16 minus 2. Now notice this negative 2 is not in the radical. Okay, so we're going to use the same technique. We've isolated our square root of x. So I know if I square the left-hand side, it will get rid of that one radical. But when I square the right-hand side, since I have multiple terms here, I'm going to have to use FOIL, multiply all this stuff out. It is not going to get rid of the radical on the right-hand side. Right? But we're going to deal with one radical at a time. So we can square this guy, and we're going to get just x on the left. But on the right-hand side, we are going to end up with, let me show you what this looks like over here. We have the x plus 16 square rooted minus 2 times square root of x plus 16 minus 2. And we have to multiply this all out. So our x plus 16 times our x plus 16, since they're both an x plus 16 square rooted, it basically squares it. We get an x plus 16. Now we've got an x plus 16 square root times negative 2. And we've got a negative 2 times the square root of x plus 16. So there's going to be 2 of those. So we're going to get negative 4 square root x plus 16. Okay, I combine those 2 terms together already. And then we've got our negative 2 times our negative 2, which is going to give us our positive 4. All right, so when we multiply out that right-hand side, it's not as pretty as you'd like it to be. Definitely do not think that it is x plus 16 plus 4, right? We have that cross term because we have to multiply each of the 2 terms times each of the 2 terms, okay? So from here, we're going to do this step again. We still have 1 radical, so we're going to get everything on one side and isolate the radical on the other side. So we can subtract x from both sides. We'll get rid of this x, and then we can combine our 4 and our 16 to get a 20. And then I don't like this. This is a negative sign, just bothers me. So I'm going to move that to the other side. So I'm going to have a positive 4 root x plus 16 equals 20. All right, so basically I subtracted x from both sides. I added 4 root x plus 16 to both sides. And then I just combined the terms 16 and 4. Now I'm going to do one last step, which is I'm going to divide everything by 4 so that we just get our radical on this left-hand side. All right, so we just simplified everything. That's all I did was simplify everything and move the radical to the left. Now we're going to square it again. All right, we've squared it again. Now we get an x plus 16 on the left and a 25 on the right. Okay, we can subtract 16 from both sides, and we're going to get that x equals 9. Very last thing we want to do is make sure that x equals 9 is a solution. If x is 9, we get 3 equals square root of 25 is 5 minus 2. So we get 3 equals 3. Yes, that works. We're good. Okay. All right, one more example. So here we have rational exponents. And really with rational exponents, we're going to treat them just like the radicals. Let's isolate it. And then let's raise it to the 4th power. When we do that, we're just going to have x plus 3 equals 16. Right? Now we'll subtract 3 from both sides and we'll get that x is 13. Right? Now notice when we raised it to the 4th power, we did take this negative and kind of make it positive. But let's just check that this still works. All right. So if x is 13, we've got 13 plus 3 to the 1/4 plus 2 equals 0. So 13 plus 3 is 16 to the 1/4 power is 2. And 2 plus 2 does not equal 0. It equals 4. So there is no solution here. Okay. And you can kind of see that when you actually go back to this original thing. We have this stuff plus 2 equals 0, which means that this stuff has to be -2, but nothing to an even power or an even root can be negative. So there's no real number that's going to be negative here. Okay, so no solution. All right, that is 2.6 for you. Go ahead and look back over these to make sure you understand everything we did, and let me know if you have any questions.